This is a first order differential equation which we will solve using the integrating factor. Now we have a sine function here which will make the right hand side require the use of integration by parts, and that will have to be done twice. Alright? Now I want you to pause this video and write down the question and make an attempt at it, given the information that I just told you. Okay, so you finished working it out? Alright, let's go ahead and work it out. So remember now, generally, when you have a differential equation in the form dy by dx plus py equals q, then you use the integrating factor. P and q can be numbers or functions of x. Alright? Now, in this case, you can see that p is equal to 3. The integrating factor will be in the form e to the integral of p dx generally. In this case, it is e to the integral of 3 dx, which is e to the, when you integrate 3, you get 3x. Now, the next step is to multiply by the integrating factor. Alright? So you're going to multiply by the integrating factor. So you have dy by dx, so you'll have e to the 3x dy by dx plus, else do you have 3y e to the 3x times 3y equal sine x. So you have e to the 3x sine x. You see that? Now the next thing, you look carefully at this. This is the result of differentiating a product using the product rule. So this comes from a product rule. Alright? Come from using differentiation using the product rule. So basically, you're finding the derivative with respect to x of some product. I'll put the product in the bracket. What are the members of that product? Here you're different. Remember, first of all, the product rule. You have two functions of x, u and v. The derivative of this product with respect to x, derivative of u v is equal to, you hold u as it is, don't change it, times the derivative of v with respect to x, you differentiate v, plus, alright, you hold v as it is, times differentiate u with respect to x. Right? So remember the product rule. So here, what was the product? Here, Seem like you differentiated y with respect to x, because the derivative of y with respect to x is written dy by dx. So one of them must be y. You differentiated y here and you hold it here. So one member of the product is y. Alright? What's the other member of the product? Of that product? Well, so e to the 3x. If you differentiate e to the 3x, you get 3e to the 3x. So the other one is e to the 3x. So that is a product, y e to the 3x. Now remember, just in case you don't remember how the derivative of e to the 3x comes out to 3e to the 3x. Let's see what happens. If you have y is equal to e to the 3x and you use the chain rule, dy by dx is equal to dy by du, where du is some substitution, and du by dx. Alright, you have the two links in the chain linked together, and it's like the du cancel du. See that? So if you let u be equal to 3x and you differentiate, du by dx is equal to 3. See that? And then y is equal to e to the u. So the y by the u is just e to the u. Just like how when you differentiate e to the x, we get e to the x. If you differentiate e to the x with respect to x, when you differentiate e to the u with respect to u, you get e to the u. So the dy by du is e to the u, which is e to the 3x, because u is 3x, times the u by dx is 3. So it's 3e to the 3x. That's how you get 3e to the 3x. 3e to the 3x when you differentiate e to the 3x. Alright? Okay, so you should remember your chain rule, differentiation by substitution. Alright, let's get rid of this now. We use it already. So here we have this is equal to, what we have over here is e to the 3x sine x. Now the next step, integrate, right? We're going to integrate. So here, what we have is the integral, so remember here, the integral of d by dx of y e to the 3x is equal to integral of e to the 3x sine x dx. Alright? Now, when we integrate the derivative, it's like the integral and the derivative cancel each other, leaving the function undisturbed. Right? So we have y e to the 3x is equal to, alright. Now the thing is, we have to integrate a product of two functions. Here is the integral of e to the 3x sine x dx. Integrate a product of two functions. Now, let's see what happened here. We're going to have to use integration by parts. Now, integration by parts comes from the The integration by parts, it comes from the product rule, right? The product rule. Remember, we looked at product rule earlier. We say derivative with respect to x of u v is equal to, you hold u and differentiate v. Let's just write dv plus you hold v, this was dv, plus you hold v and differentiate u. Right, so remember what happened? uv, you hold u, differentiate v plus you hold v, differentiate u. Now if you integrate, integral, when you integrate, the derivative of this will just leave uv, and that is equal to integral of u dv plus integral of v du. Alright, so this leaves the integral of u dv plus the integral of v du, and then you say make this a subject. So the integral of u dv, oh boy, dv is equal to uv minus the integral of v du. Alright, that's the integration by parts formula. Alright, so now that we see it, let's bring it up close to this and use it. Now let's use u as e to the 3x. So let u be equal to e to the 3x, and let dv be equal to sine x. Make sure you're following, you know. Remember, it's the integral of u dv. Alright? So e to the 3x is our u, and sine x is our dv. You following? See that? Now, if we differentiate u, the u would be, now remember the chain rule, right? 3e to the 3x. We go from u to the u by differentiating. Now we go from dv to v by integrating. If we integrate sine, if you look at or you remember your table of derivative, when you differentiate cos, you get negative sine. You get negative sine. If you go the other way, from negative sine, you get positive cos. That means if you integrate negative sine, you get positive cos. Right? And if you therefore integrate positive sine, you get negative cos. So it's negative cos x. Right? If you don't remember what I did a while ago, look at your table of derivatives. Going from left to right, you're differentiating. You're going to get cos on the left and minus sign on the right. Going from right to left, you're integrating. So integrate dv to get v, you integrate sine to get negative cos. Now let's put them together. So the integral, this is equal to the integral of u dv. This is u dv. Integral of u dv equal uv, or uv is equal to u, our u here is e to the 3x. V, our v is negative cos x. Let me put a multiplication sign so it doesn't look like we're subtracting. Alright? Now, minus the integral of v, which is negative cos x, du is 3e to the 3x, and the variable is x, so dx. Alright? So what we have here is equal to negative e to the 3x cos x minus negative means with plus the integral of, let's put this first, can put 3 outside, 3 e to the 3x cos x dx. Alright? So therefore, the integral of e to the 3x sine x is this. The integral of e to the 3x sine x dx is this. Coming from this. Alright? Now, we need to look at this part and see how we're going to deal with it. We need to find out this integral. So, the integral of e to the 3x cos x dx. We're going to have to use integration by parts again. Now, remember, it is the integral of u dv equal uv minus integral of v du. Let our u be equal to e to the 3x. Our dv equals cos x. So that means that our du is equal to, going to be 3 e to the 3x, and our v, what is v? V equals, so when you look at your table of derivative, when you differentiate sine, you get cos. That means when you integrate cos, you get sine. Going from dv to v, you have to integrate. So you integrate cos to get sine x. Alright? You see that? We run out of scrolling space. We can't scroll down anymore. So let us draw a line and separate the board. Let's make our line up here and work on the right hand side of that line. Alright? So here now, let's work this out first. So therefore, integral of e to the 3x cos x dx is equal to the integral of u dv equals u, which is e to the 3x, equal u v. V is going to be sine x minus the integral of v, which is sine x du. Du is 3 e to the 3x. See that? So let's just copy this thing. I want to copy it properly. Let's move some of these. Alright, let's try again. Let's copy all of this. Okay, good. And combine them and move them up here. I want to work on this. Now, this is what we have here. This is this integral. Now, what did we have before? We have the integral of e to the 3x sine x dx equals all of this. Alright? E 3 times e to the 3x cos x. E to the 3x cos x. Now, let's copy this too and put it over. Copy and combine and put it over here. Where's the thing that I just copied? E to the 3x. Combined it and should have it over here. Oh, here it is. I lost it for a while. So this is what we had before. Now, here, what we can write here is that the integral of e to the 3x sine x dx is equal to negative e to the 3x cos x plus 3 times, and then this integral, we can put a bracket there and write e to the 3x sine x minus the integral of sine x e to the 3 e to the 3x dx. Alright? So that's what we have. Now, here, let's look at this. Let's open the bracket. This is equal to negative e to the 3x cos x plus, this is going to be 3 e to the 3x sine x minus, you have 3 here, we'll multiply this 3, we can put it outside the integral sign, 9 integral of sine let's put the e to the 3x before. So we have integral of e to the 3x sine x dx. Okay. Now, on the left hand side here, you have the integral of e to the 3x sine x dx. Alright? Now, let's see something here. E to the 3x sine x dx. E to the 3x sine x dx. So let us add 9 e to the 3x sine x dx to both sides. Let's add that to both sides. We would have integral of e to the 3x sine x dx plus 9 integral of e to the 3x sine x dx. When you add it over here, it will subtract itself, right? Then you have all of this minus, no, equals negative e to the 3x cos x, right, plus 3 e to the 3x sine x. So you see that? Now, over here, this gives us 10 e to the 3x sine x. No, 10 integral, I mean. 10 integral of e to the 3x sine x dx is equal to, and then we have, let's put the 3 e to the 3x first. This is 3 e to the 3x sine x minus e to the 3x cos x. Alright? So this is what we have. That's the integral. No, we didn't put a plus c yet. Right? I'm going to be adding it later. It would make sense putting a plus c on the left and a plus c, well, it would be something else on the right. You could subtract them to get yet a new constant, and we don't know what the constant is. So we wait until we do both left and right to put the plus c. Alright, so remember what we started out with is this. This is all the right hand side of this, you know. This is e to the 3x sine x dx. You have e to the 3x sine x dx. Alright? Now we had gone through integrating all of this thing, right? So we can put a constant of integration there now, plus c. Now, if we divide both sides by 10, the 10 would go from here, and we have 3/10, 3 over 10, and this time 1/10, right? Plus c over 10. C over 10 would be some other constant. Let's keep it as C. Alright, that's the right hand side. Now, on the left, we have the integral of the derivative of y e to the 3x. We have the integral of d by dx of y e to the 3x. Y e to the 3x. Equal. What we had was integral of e to the 3x sine x dx. But we find out that the integral of e to the 3x sine x dx is all of this. So we just write all of this. So it is 3/10 e to the 3x sine x minus 1/10 e to the 3x cos x plus c. Now, when we integrate a derivative using the same variable, it's like they cancel each other. So, what we have here now is that y e to the 3x is equal to 3/10 e to the 3x sine x minus 1/10 e to the 3x cos x plus c. Now, we want to write it as y equals something. So we divide by e to the 3x and see what happens when we divide by e to the 3x. What do we get? Y equals 3/10 e to the 3x would cancel e to the 3x, so we have sine x minus 1/10 e to the 3x would cancel e to the 3x, so we have cos x plus c over e to the 3x. Alright. C over e to the 3x. So, that's what we have there. Alright. Now, here, suppose now we have an initial condition. We run out of scrolling space, so we're not able to scroll down anymore. Let y of 0 equal 1. That means when x is 0, y is 1. So 1 equal sine of 0 is 0. So this would be 0. Cos of 0 is 1. So that's minus 1/10 plus c over e to the 0 is 1. So it's just c. Now, we do a transposition. C would be 1 plus 1/10. Using common denominators, this would be 10 over 10 plus 1 over 10 equals 11 over 10. So C would be 11 over 10. So if you look at those initial conditions, then this would be 11 over 10 over e to the 3x, which can be written as 11 over 10 e to the 3x. Alright, so that would be our solution. In the next video that I do, I want to solve this again using the Laplace transform. It will be interesting to see what we get. It should be the same thing, but we'll see.